Good day everyone, welcome again to Ethereum Physics, and today we look at heat capacity and latent heat. We begin by looking at specific heat capacity versus heat capacity. Heat capacity is the amount of heat energy required to raise the temperature of a substance by 1 degree Celsius or 1 Kelvin. This gives rise to the formula capital C equals E over change in temperature. Please recall that the change in temperature in degrees Celsius is the same as in Kelvin. Hence the unit for heat capacity will be joules per degree Celsius or joules per Kelvin. Specific heat capacity, on the other hand, involves a specific mass, known as a unit mass, or a mass of 1 kilogram. So the definition for specific heat capacity is the amount of heat energy required to raise the temperature of a unit mass, or 1 kilogram, of a substance by 1 degree Celsius or 1 Kelvin. As a result, a formula is given as common C equals E over mass m by change in temperature, where the unit is given as joules per kilogram Kelvin or joules per kilogram degrees Celsius. But what is the relationship between heat and specific heat capacity? Well, if we make energy the subject of the formula in both equations shown, we will get E equals C delta theta and E equals mc delta theta. Since both are equal to energy, we equate both equations. As a result of that, and by cancellation of the common term, heat capacity equals mass by specific heat capacity. Specific latent heat of a substance. This is the amount of heat energy required to change the state of 1 kilogram of a substance without changing its temperature. As a result, we get L, where L represents specific latent heat of a substance, equals energy over mass, the unit for which is given as joules per kilogram. So far, we have met two equations for energy. E equals mc delta theta, where delta theta represents a change in temperature, and E equals ml, where that specific equation involves a change in phase or state. Our states of matter involves, or are called, more specifically, solids, liquids, and gases for this lesson. Specific latent heat of fusion. This involves a change in state from a solid to a liquid. Once again, there is no change in temperature, and the equation remains the same. Specific latent heat of vaporization follows suit, where the change in phase involves liquid to gas. Let's look at two past paper questions, the first being June 2012, paper 2, number 3b. The question asks for energy required to change 2 kilograms of ice at 0 degrees Celsius to steam at 100 degrees Celsius. At 0 degrees Celsius, which is the melting point of ice, there's a change in phase. So our equation is E equals mLF, where LF is the specific latent heat of fusion, which is given in the constants at the end of the question. We therefore get energy equals our mass in kilograms by 330,000, giving us a value of 660,000 joules. The next stage involves a change in temperature, where water is allowed to raise its temperature from 0 to 100 degrees Celsius. Our equation therefore is E equals mc delta theta, giving us a value as shown below. Now it's important to note that the change in temperature is 100 minus 0. Finally, we reach the point where we add water at 100 degrees Celsius changes to steam at also 100 degrees Celsius, involving a change in phase relationship where water changes into steam. 100 degrees Celsius being, of course, the boiling point of water. It should be noted that an assumption made here is that the mass remains the same throughout each of the various types of reactions that we have met. As a result, the total energy required to change from water at 0 degrees Celsius to steam at 100 degrees Celsius would be the sum of all three energy values, giving us a value of 6 million joules, or 6 by 10 to the power of 6 joules, also known as 6 megajoules. Finally, we are asked to find power. But what is power? Power is the rate at which work is done, or energy per unit time. As a result, our total energy divided by time gives us a value of 1000 joules per second, or 1000 watts, where 1 joule per second is the equivalent unit of a watt. June 2021, paper 2, number 4. In this particular question, we see an actual visual representation of the previous question given. However, the mass is given in grams. It's also important to note that the constants are also given in terms of grams and not joules per kilogram Kelvin or joules per kilograms. So as a result of that, the information can be written as follows. The mass of ice was given as the mass of water plus its melted ice minus the mass of water, which is 20 grams. We did not need to change this to kilograms, but it was given nonetheless. As a result, in the next particular part of the question, we use what is called the method of mixtures, where heat lost by the water is actually heat gained by the ice, where water is the hot object and ice is the colder substance or object. Finally, the specific latent heat of fusion can be found by E equals mLF. Thanks for watching. Take care.